Introduction to polynomials. A polynomial sounds really scary. It's an expression involving sums of powers of x with whole number powers. But it's less scary when you realise that linear equations are polynomials, quadratic equations are polynomials, cubics, and so on. So a bunch of the things that we've been dealing with. Don't look too closely at this yet because it can look a little bit scary. This is a polynomial. You can see that all the powers of x are whole number powers. I've sorted them or arranged them from the highest power of x down to the lowest power of x, and you can see that what this is saying is I'm going to start from my highest power of x. This is one power further down, this is one power further down, all the way down to x to the power of 0, which is of course just 1. So this is technically negative 4 times x to the power 0. So it's negative 4. This is our constant. So all this is saying is all of these x's, powers of x, can have coefficients. And by saying a subscript n, we're just saying this is the coefficient that belongs to the nth degree of x. This is the coefficient that belongs to the n plus 1th degree of x. So the degree of x is the power, and the degree of the polynomial is the highest power of x. So this is a quartic 4, or we could say a polynomial of degree 4. The highest power of x is our leading term, so our leading term here is 3x to the power 4. Our constant is the one where there's no power of x occurring. And when we name polynomials, any polynomial can be named px. If we wanted to use a problem where we had two different polynomials, we could have a polynomial called q of x. Types of polynomials are named by degree. So a polynomial of degree 0 has the highest power of x of 0, that's a constant, e.g. 5. So actually a whole number is a polynomial. Linear, our highest degree of x is 1. So for example, 3x minus 2. And if you can see, if that equaled y, we'd have a linear equation. A quadratic, we know our quadratics. Now that's annoyingly named, but that's our 2x squared plus 3x minus 4 type of thing. So we know quadratics because it's x squared. It's a little annoying that it's got the name quad with 4 in it. We have cubics. Highest power is x to power 3, so we could have negative 3x cubed. Now you don't have to have all the powers of x for it to be a polynomial. So you don't have to have a power of x squared, because if I don't have that, all it means is that the coefficient of x squared is 0, plus 0x squared, plus 0x. If they're not there, that's what's happening. And I'm just going to add a constant in on the end there. So this polynomial, negative 3x cubed plus 4, the other x's have a 0 coefficient technically. So you don't have to have them all in there. And of course then there's a quartic, and we gave an example of that up here. And then from there on you would just say a polynomial of degree whatever, so a polynomial of degree 8. Now in the 10A course this year when I'm doing this, which is 2018, we don't really need to spend a lot of time on this. So I've set a couple of questions and I'll just go through this. So here you can see they've defined two polynomials. This is px and this is q of x. and they'd like us to multiply those together. So we've got x squared plus x minus 1 times x cubed plus 2x plus 3. Now, if we wanted to just expand that out, we're going to have to do this x squared times each of these, this x times each of these, this negative 1 times each of these, and simplify. It's actually going to end up being quite long, and I would usually suggest being quite careful. X squared times x cubed. Because our polynomials here have the highest power to start with, we'll get the highest power of our answer at the start. X squared times 2x. X squared times 3. That is the first term multiplied out. X times x cubed. Now see, we pop back up to a higher power. X times 2x. X times 3. Negative 1 times x cubed. Negative 1 times 2x. Negative 1 times 3. So having expanded it all out, we then need to gather like terms. There's only going to be one of your highest power because we didn't have any double ups with an x2 and x3, but it's worthwhile looking for double ups in the other powers. Obviously you don't have to do my little squiggly method, I just find it helps me to track that I've done everything. So it's x5 plus x4, make sure they go in order of decreasing powers of x, plus x cubed plus 5x squared plus x minus 3. So I might leave off the last example there, but you can see how we would expand.